Hello and welcome back to Project 380. On this video I'll be installing the turbo manifold, the turbo and the lines. So in the last couple of weeks I've been waiting on a few things to turn up, which meant I couldn't do anything to the engine or the car. So I had a bit of spare time on my hands and I was dry fitting everything this side, checking all the threads, getting the right fittings and make sure everything fits. But I had an issue with the turbo manifold. I've seen quite a few people have issues with this particular manifold. I'm gonna guess in the factory the quality control isn't up to scratch, but it seems like different people are having different issues. But I'll show you the issue I'm having with mine. At first I thought maybe this flange isn't straight and true, maybe there was a bit too much heat put into it when it was welded up, or maybe it just was never flat in the first place. But if you rock it, it seems like it's bulging out there and the sides aren't touching. But I put a flat across the face and that isn't the case. What my issue actually is further down here. So my issue is with this bend here on cylinder number 2 runner. It seems like it's touching this protruding bit of the core plug. So there is no gap here whatsoever, which is causing the manifold not to sit flat, so I'm going to have to do something about it. So it's very hard to see, but I didn't want to grind it any further. I didn't want to touch that core plug and damage it. But there is a little gap there now. So now it's not touching. I'm happy that this could go on permanently, but I better paint that bare metal first. Well, that's not something I wanted to do, or did I expect to do. But after seeing all those videos of horror stories, I think this was the least of my worries. I'm going to leave this paint to dry overnight. I'll see you tomorrow. So that's had overnight to dry. Now it's time for the exhaust manifold. But before we put that on, we want to make sure our mating surface is really clean. This is something that can be done when your engine is away at the machine shop. They'll take a light skim like they do to the bottom of the head to make sure this is clean and flat. But I forgot, so I've just cleaned it up the best I can. So now I can put the manifold gasket on. I like to favour the multi-layered steel gaskets rather than the other type because I trust these a little bit more. Same with the manifold itself, we're going to make sure that is nice and clean and pop it on. Now the standard manifold nuts need to be torqued down to 33 foot-pound. Now this is a turbo build and I don't know whether I need to go any tighter. So I'm going to do them up to 33 foot-pound and then hopefully if I don't have any blows I've done the right thing, but if I do I'll just try and nip them up a little bit first before I change a gasket. These are going to be a little bit hard to torque as this nut and this nut is near on impossible to get with a torque wrench. So I'm going to have to do them with a ratchet spanner just by feel. I'm going to try do them in a cross-like pattern, but that is going to make it hard with the ones that I can't get to with a torque wrench. ahead and put the turbo flange studs in with the double nut method. Now it's time for the turbo gasket itself. Now the bit I've been waiting years for. Time to finally put the turbo onto the engine. I also don't know what to torque these down to, so they're going to be torqued down to 33 foot-pound as well. Now, I'm sure you've all heard the expression clocking a turbo, and what that actually means is rotating the CHRA, which is the middle bit, round to where it needs to be, or rotating the cold side round to where it needs to be. Now, this isn't possible on every turbo, but it is easier on a turbo which is controlled by an external wastegate, as you don't have an actuator plunger to worry about. Now, why do we need to rotate the CHRA? Well, the drain for the oil really needs to be pointing directly down to ease the flow of the oil. So I need to rotate this so the drain is level, and to do that I've just undone all the pressure plates on the hot side and on the cold side, and now I can simply move it to where it needs to be. But in my case, what I actually need to do is rotate this round so I've got access to the drain, as I need to put the drain in first, because where I need it I won't be able to gain access to this bowl. So I have just got a nice aluminium drain with an AN10 fitting that I bought off eBay. Now I can spin it round where it needs to be. Now to lock it off, I'm just going to do up the hot side of the turbo. Because I've moved the cold side, I don't know whether this is in the right position until I get this in the car. It's a good job I bought some extra thin spanners to get this last one right in here, which I can't get the normal spanner in. Now I'm going to give them all just a really good nip, as you can't get a torque wrench in here. I've just got to do it by feel. Since I'm here, I'm going to pop the external wastegate on. Two reasons: I want to check the clearance for my oil drain, and I'm going to make sure nothing else can fall back into the manifold. I've just nipped that up for now, as I don't know whether the exit of the external wastegate is going to be in the right position. I'll need the engine in the car and the downpipe on to check that. Now up the top here is the oil feed, and this is where it starts getting complicated, and it varies all depending on what turbo you have and what setup you have. But in here needs to go an oil feed union. On my setup, because this turbo is a journal bearing turbo rather than a ball bearing turbo, it's suggested that I use no restrictor in the unit. But in the case if you are using something like a Garrett or a Borg Warner, you'd have to do a little bit of research to find out what restrictor you would need here. In the future, if I ever see smoke coming out of the exhaust, this may mean that I've got too much oil flow into the turbo and I'll eventually have to put a restrictor in. But for now, I'm just going to put a standard union with no restriction in. Now I need an oil source to feed the turbo. This could be taken off of many places on this engine, and it does differ whether you've got a Mark 1, a Mark 2, a Mark 2.5 or a 1.6, as each engine is different. Some people like to take a T off of where the oil pressure sensor is and feed it from there and round. On some of the earlier Mark 1s, you could take it from the block down the bottom here, but on my engine, which is a Mark II head, this rail here is actually an oil rail, and I'm going to take out this little Allen bung here, and I'm going to take my oil feed from there, which is perfectly fine. Now to feed our turbo from here, I'm going to need a turbo line, and what I've found is a Black Cats Motorsports turbo feed line, which is a 4AN line, and this is almost the perfect length for me to run from here to the turbo. The other option is, if you had a different turbo, maybe a lower mount turbo, you can actually use this Allen bung here. So I'm going to go ahead and take this one out, and I'm going to take the end off of the turbo line and screw that into the block first. Now I don't want to take any chances. These I believe are a NPT fitting, which is a self-sealing fitting, but I've gone ahead and put a little bit of PTFE tape down it just for a little bit of extra security. So I've gone ahead and secured the oil feed line to the rocker cover using these 3 bolts. This is for a couple of reasons. It's to drag it away from the downpipe to reduce a little bit of heat, and it's going to keep it nice and secure so it's not going to rub on anything and burst. If you are doing this, make sure these aren't too tight and that you can still wiggle the pipe, and if you are going to use the rocker cover bolts, make sure to retorque the whole rocker cover back down to how it should be. So now the turbo has been fed oil, that oil also needs to drain. Using the AN10 fitting I put on the turbo earlier, I've made an AN10 line to go to the fitting on the sump. Now the drain fittings don't need to be overly tight, that's why I've only used a Jubilee clip down the bottom, as this doesn't carry pressure, it's just a gravity drain. This turbo, like many others, is also water fed, here and here. On this turbo it doesn't really matter which one is water in and water out, as it's all the same. So I've got some M14 to AN6 adapters with a little fibre washer on. So I've made a couple of AN6 lines up. The first one I'm going to install is going this side of the turbo to the AN6 fitting that I put in when I put the timing belt in. Fingers crossed I've made this pipe small enough to get away from the belts that are going to be here, but far enough away from the exhaust manifold where it doesn't get affected by the heat. If I feel this starting to get a bit brittle, I'll replace it and then put some heat-proof covering over it. So for the coolant out of the turbo, I've got a AN6 90-degree fitting with a length of pipe on it, as I'm not quite sure where I'm going to plumb it into down here yet. Some turbos don't require the coolant lines at all, but the coolant will benefit you. It doesn't essentially cool the turbo down, but what it does is draw the temperature away from the turbo once the engine's stopped, to help prevent something called oil coking, where the oil dries up in the pipes and chokes the pipe up, reducing the flow over time. That's it for this episode. Join me next time when I've got more exciting stuff to bolt onto this engine. Don't forget to like and subscribe, and catch me in the next one.